This video is about how to find relative maximum and relative minimum of a function. First derivative test for locating relative extreme. Let's see with the critical number of a continuous function f and that the derivative f prime is defined for x close and on both sides of c. Determine the sign of the derivative f prime x to the left of x equals c and then determine the sign of f prime x to the right of x equals c. Number 1. If f prime x is positive to the left of x equals c and f prime x is negative to the right of c, then f has a relative maximum at c, f of c. Number 2. If f prime is negative to the left of c and positive on the right of c, then f has a relative minimum at c, f of c. If f prime x has the same sign on both sides of x equals c, then f has neither a relative maximum nor a relative minimum at x equal to c. Example 1. Applying the first derivative test. Let's consider function f of x equal to x squared minus 8x. First, find the critical numbers of f if any. Then b, find the open intervals on which the function is increasing or decreasing. And c, then apply the first derivative test to identify all relative extreme. Okay. Step 1. Find the critical numbers. So let's start with f of x equal to x squared minus 8x. So let's find the first derivative. So f of x becomes f prime x squared becomes 2x, and 8x become 8. Now we set the 2x minus 8 equal to 0 and solve for x. Move the minus 8 to the right and divide by 2. So x equals to 4. Now f of 4 exists, so 4 is the critical number. Now we find the open intervals on which function is increasing or decreasing. So in part A, we just found critical number 4 for x equal to 4. Now we can write the open intervals. So since the given function is polynomial, so the domain is negative infinity to positive infinity. So the interval will be negative infinity to 4, 4 to infinity. So now we test this in first interval, negative infinity, 4 for increasing and decreasing. So you can pick a number in the interval minus infinity, 4. You can pick, let's say, 0 and substitute in the first derivative f prime x equal to 2x minus 8. So it becomes f prime 0, 2 times 0 minus 8 equal to minus 8, less than 0. So we can conclude f of x is decreasing over the interval negative infinity to 4. Now we test the interval 4 to infinity for increasing and decreasing. So pick a number in the interval 4, infinity. You can pick, let's say, 5. You can pick 6. So let's say pick 5. So we substitute in the first derivative f prime x equal to 2x minus 8. So substitute x equal to 5. So this becomes f prime of 5 equal to 2 times 5 minus 8. 2 times 5 is 10, so 10 minus 8 is 2. Now 2 is bigger than 0. So we can conclude f of x is increasing over 4 to infinity. So now what we have here, f of x is decreasing over minus 4 to 4, and f of x is increasing over 4 to infinity. So now we apply the first derivative test to identify relative extrema, if any. So use the results of part B. From part B we have f of x is decreasing over minus infinity to 4 and increasing over 4 to infinity. We put this information in the number line. So you can see minus infinity to 4 is decreasing. From 4 to infinity it was increasing. And you can see this is the lowest point. So this is called the relative minimum. So the 4 comma f of 4 is relative minimum. So now it's be 4 and put this 4 back in this one. From 4 square minus 8 times 4. So simplify gives you 4 comma minus 16 is relative minimum. So now consider this function f of x equal to minus 7x cubed plus 21x plus 3. So let's find the critical numbers of f, if any. Find the open intervals on which function is increasing or decreasing, and then apply the first derivative test to identify all relative extreme. So let's see, to find critical numbers, start with f of x equal to minus 7x cubed plus 21x plus 3. Let's differentiate with respect to x, and this becomes f prime x equal to minus 7 times 3 minus 21x squared plus 21 times 1, which is 21. And the derivative of 3 is 0, so we ignore that. So now we set the first derivative to 0, which means set minus 21x squared plus 21 equal to 0. So we can factor out negative 21 and give x squared minus 1 equal to 0. And we can get rid of minus 21 by dividing minus 21 both sides. So now we have x squared minus 1 which is equal to 0. We factor this, it becomes x plus 1, x minus 1 equal to 0. Set each factor to 0. X plus 1 equal to 0 implies x equal to negative 1. X minus 1 equal to 0 implies x equals to 1. So now we have critical numbers, negative 1, positive 1. Okay. Now we write the open intervals on which function is increasing or decreasing. So these are the critical numbers, negative 1 and 1. So we write the open intervals, minus infinity to minus 1, minus 1 to 1, and 1 to infinity. So we test each of these intervals. So let's test first interval, negative infinity to minus 1 for increasing and decreasing. So pick a number in the interval, negative infinity to minus 1. You can pick x equal to negative 2. And we substitute in the first derivative, which is f prime x equal to minus 21x squared plus 21. So we substitute x equal to negative 2. So this becomes f prime of negative 2 equal to negative 21 times negative 2 squared plus 21. So this is 4 positive times negative 21, negative 84 plus 21 gives you negative 63, less than 0. So we can conclude the f of x decreasing over this interval negative infinity to minus 1. Now we test the interval negative 1 for increasing, decreasing. So we pick a number between, or in this interval negative 1 and 1. Let's pick x equal to 0. Substitute in the first derivative, f prime x equal to negative 21x squared plus 21. So we substitute x equal to 0. This becomes f prime of 0 equals to negative 21, 0 squared plus 21. So this becomes 0 because 0 squared is 0. So we minus 0 plus 21 is positive 21. So 21 is greater than 0. So we can conclude that the interval function is increasing over this interval negative minus 1 to positive 1. Okay, now we test this interval 1 to infinity for increasing and decreasing. Pick any number in the interval. So you can pick 2 or 3 or 4. So let's say pick x equal to 2. Substitute x equal to 2 in the first derivative, f prime x equal to negative 21 x squared plus 21. So this becomes f prime 2 equal to negative 21, 2 squared plus 21. Again, this should be 84 negative plus 21, which is negative 63 less than 0. So we can conclude the f of x is decreasing over 1 to infinity. Okay, now we apply the first derivative test to identify all relative extrema. From part B, f of x is decreasing over minus infinity to minus 1. increasing over -1 to 1 and decreasing over 1 to infinity. So we can put this information on the number line, and see it looks like -21 minus is decreasing, -1 to 1 is increasing, 1 to infinity is decreasing. So you can see -1 to the left side of -1 is decreasing, and to the right side of -1 is increasing. So we can conclude that -1 comma function evaluated at -1, which is equal to -1 7 times -1 a cube plus 21 times -1 plus 3, which is equal to -1 comma 11 is a relative minimum. Okay, now we can see from the graph that to the left of 1 function is increasing, and to the right of 1 the function is what? Decreasing. So we can conclude that at 1 comma function evaluated 1, which is equal to 1 comma -7 times 1 cube plus 21 times 1 plus 3, which comes out 1 to 17, so is a relative maximum. So the answer is relative maximum is 1 to 70, 1 comma 17, and relative minimum is -1 comma -11.